Hello everyone, welcome to Module 7 of Basic Electrical Engineering, which is based on RLC series and a parallel circuit. So this is the outline of this module. At the end of this session, the learners are able to derive the relation between voltage, current, power in series and parallel RLC circuit, solve numericals based on RLC series and parallel circuit. So let us understand first resistance and inductance which are connected in series, that is single phase RL circuit. Let a single phase AC supply which is given by V is equal to Vm sin omega t is applied across a series circuit of resistance R ohm and inductance of L Henry as shown in the figure. If the frequency is f hertz, means this omega is equal to 2 pi f, that is the frequency of f hertz is given, then the inductive reactance is given by xl is equal to 2 pi fl ohm. Okay, the inductive reactance is xl is equal to 2 pi fl ohm. If the current flowing through the series circuit is if the current flowing through the series circuit RL, the voltage across R is given by the voltage across current is I ampere, the voltage across resistance is given by, that is voltage across resistance is equal to nothing but the current flowing through it and resistance. So that is VR, voltage across resistance VR is equal to IR. Similarly, voltage across inductance is given by voltage across inductance VL, its effective value is XL, so it is I into JXL, that is VL is equal to J I into XL. Why am I writing J? Because XL is always come with the J. So I into J XL. Applying KVL in this loop. So if I apply the KVL in this loop, if V is the RMS value of this supply voltage, the V is equal to VR plus VL. It is not normal arithmetic addition. It is what? It is not algebraic addition. It is what? Arithmetic addition, that is vector addition. So V phasor is equal to VR phasor plus VL phasor. Substituting the value of VR and VR and VL from the above equations, so we will get V is equal to IR plus J I phasor XL. So taking the I phasor as a common, what will remain in the bracket? R plus J XL. So I replace this term I plus J XL is known as the Z, where Z is equal to R plus J XL, which is known as the impedance, that is opposition offered to the AC current. This Z is nothing but what? Opposition offered to the AC current. How will calculate this Z? Z is equal in the polar form. This Z can be represented in rectangular form. It is R plus JXL. Z is equal to mod of Z at an angle of phi. Okay, so I will calculate the mod of as this is the R plus JXL is the what? It is the complex number, or you can say it is the rectangular value. So I can convert this into polar value as magnitude is equal to under root x square plus xl square, that is real value square plus imaginary value square, angle tan inverse of imaginary value divided by real value, that is tan inverse of xl by r is the value of phi. So this is the VR, VL, the current flowing is I, R and L is connected in series. So let us draw the phasor diagram. Okay, this is a series circuit. So I can take the reference phasor anyway, anything. Okay, so I can take the voltage as a reference, I can take as the current as a reference. For simplicity, I will take the current as a reference. Why? Because in series circuit, the current is same. So taking the current as a reference value, so reference is taken as the current. So reference, the I is the reference value of the current. Okay, phasor are rotating in anti-clockwise direction. So how will get the VR? VR will be in phase with I, because we know that in resistive circuit, this VR is equal to I into R. That is, in resistive circuit, voltage across resistance and current flowing through it is in phase. So this is the current flowing. So VR into IR will be in phase with this I. Okay, so coming to this inductance, voltage across inductance leads to the current by 90 degree, or the current lags to the voltage across inductor by 90 degree. So this is my current. voltage will lead to its by 90 degree. The voltage will leads to its by 90 degree. We know that the total voltage V is equal to VR plus VL. So adding this VL, okay, constructing the parallelogram between VR and VL, the line joining from the origin to this corner, so this will represent my V. So angle between this voltage and current, it is nothing but a phi, which is represents the power factor angle. So what we can conclude from this, in this the voltage, if we see the voltage is leading to the current by 5 degree, or you can say the current is lagging to the voltage by 5 degree. Okay, so this is the RL circuit where the inductance is where a current is lagging to the voltage by I degree. If this phi is equal to 90, means it is pure inductor. If it is phi is equal to 0, it means it is pure resistor. Okay, so pure resistance. So how will calculate the instantaneous voltage and current equation? So instantaneous voltage and current equation, suppose instantaneous voltage equation is equal to Vm sin omega t. So current lagging it is behind by 5 degree. So I of t is equal to Vm sin omega t minus phi. Omega t minus phi. So I will calculate the instantaneous power. The instantaneous power, small p is equal to small v into I. That is Vm sin omega t into Im sin omega t minus phi. So Vm sin Im divided by Vm Im is taken as a common. Sin A into sin B can be calculated as sin A minus cos A minus B, that is omega t minus phi, that is cos phi, and sin A plus B divided by minus cos A plus B divided by 2, that is cos 2 omega t minus phi. So Vm Im by 2, this is 2, this is due to this formula. Okay, so Vm Im by 2. So if we look into this term, this Vm Im is multiplied with cos phi, Vm Im by 2 is multiplied with cos of 2 omega t minus phi. So Vm Im by 2 cos 2 omega t minus phi indicates that it is the frequency, it is the double frequency term. So 2 multiplied means it is double frequency term. Vm Im by 2 cos 2 omega t minus phi is a fluctuating power whose average is 0. Okay, so whose average will be 0 over the half cycle, similar full cycle. Similarly, Vm Im cos phi is a constant power because it is not depending upon time. So it is a constant power whose average is non-zero over the full cycle. Hence, average power of Vm Im by cos 2 omega t minus phi is 0, where this is a constant. So average power P, capital P, is equal to Vm Im by cos phi. So this splitting this 2 into root 2 into root 2, Vm by root 2, Vm by root 2. So this is nothing but RMS value V into I into cos phi, V into I into cos phi. That will be the power consumed by AC circuit. So if we represent in the waveform, so this is my voltage phasor, which is indicated by black color. Voltage phasor, the current lagging to this voltage by 5 degree, the current is lagging to the voltage by 5 degree, and if we take the multiplication, instantaneous multiplication of V and I, we can see this is the what, fluctuating power. Okay, so average power will not be 0, average power will be a constant power. Okay, if we take the average of this will be the constant power. Okay, so this is about what, RL circuit. So how will define the active power? Active power, it is the power consumed by the circuit. It is the multiplication of RMS value of voltage, current and power factor. So P is equal to V into I into cos phi, whereas cos phi is known as power factor. How we define the power factor? Power factor is the cosine of angle between voltage and current. So P is equal to VI cos phi watt. How will define the reactive or imaginary power? Reactive or imaginary power is denoted by Q, and its unit is VAR, volt ampere reactive. It is the multiplication of RMS value of voltage, current, and the sine of angle between the voltage and current. That is Q is equal to RMS value of voltage V, RMS value of current I, sine of angle between voltage and current, that is phi VAR. Phi VAR. So it is the value of Q. How will you get the apparent power S? Apparent power S is equal to it is the multiplication of RMS value of voltage and RMS value of current. So S is equal to VI, that is VA. So S is equal to P plus JQ. Generally this S is equal to what? P plus JQ, that is VI cos phi plus JVI sin phi. Okay, so if I take the common VI term, so VI is equal to cos phi plus J sin phi. Cos phi plus J sin phi is equal to 1. So VI, S is equal to what? VI volt ampere. The unit of apparent power is volt ampere. So there are some useful triangles. So if we go into this phasor diagram, we can see this triangle. This is what VR. This is equal to what? VL into this is VL, that is I into J XL. So similar triangle is represented here. So VR, so this will represent my VL. VR is equal to I into R. VL is equal to JI into XL. So line joining by this is nothing but a total voltage V, which is given by I into Z. Okay, suppose I is cancelled from all this, so this angle represents what? Phi. If I is cancelled from all this, so this will remain resistance R. This is XL and this is Z. So it is known as impedance triangle. This is a voltage triangle, impedance triangle. If I is cancelled from all these terms, so R, XL and Z. Similarly, power triangle is what? P, Q and S. So this is the angle, phi is the angle between P and S. So I will calculate cos phi. Cos phi may be equal to R I by R divided by IZ, or you can say VR by V. It will be R by Z. Cos phi may be P by S. That is, power factor can be calculated by different formula. Thank you.